Hello. Today we're going to look at these things called simulated probabilities. We're just kind of going to do a little intro to that. Now, to give you just kind of an overview, there's three ways of dealing with probabilities. There's observational probabilities. So if I have a coin and I flip it 5 times, you could say 4 out of those 5 times were heads. Uh, and that would be something you observed. There's theoretical probabilities, like the probability you flip a head is 0.5, and you can use theoretical probabilities to find more complicated or other probabilities if you'd like. And then there's these things called simulated probabilities. Simulated probabilities are when we try to use a computer program or a calculator to try to simulate a real world situation. Now, so here's more of a definition. It says the imitation of chance behavior based on a model that can accurately reflect a phenomenon is considered under consideration is called a simulation. Now, there's many applications. They do weather simulations. Uh, a lot of computer programmers make simulations for whether or not a particular program is going to work, or whether or not a research idea is going to be a good research idea. It's done all the time in genetics uh, to kind of find out what's happening. There are many, many practical applications of simulations. Now, when we do in a simulation, or when we do a simulation, we want to assign digits or have some way to represent the outcomes. There's going to be some randomness involved, and we need to figure out how to clearly state what our rules are. Then we want to simulate as many repetitions as possible, tally the results, and then state some sort of conclusions. Now, let's take an instance where a couple wants to have kids. They want to simulate as many the possible outcomes. Now, how can we simulate with a die having boy versus girl? Well, what we can do is we can say we roll one die, and numbers 1 through 3 will represent that they had a boy. Then they could have 4 through 6 represent that they have a girl. And then they could take the die and keep rolling it until they get the solution that they want. Now, if you want to simulate having kids with a coin, you can just say heads equals boy, tails equals girls, and then you can flip the coin, and then you can see what your outcomes are. If we want to do this with random numbers, there's many ways you can do this. You could say have numbers 1 through 50 be boy, 51 through 100 be girl, or you could just have something more simple where 1 equals boy and 2 equals girl. And all you have to do is make sure that the probability is equal in the numbers. So how we do this from here is we go to our calculator and we do our random numbers. So I got to clear out of the screen. So you get to your blank screen and hit math, go over to probability menu, and go down to random integer, number 5. We're going to do a random integer from 1 to 2, and our first one is a girl, then a girl, then a boy, then a girl, then a boy, and so on as you go through. Now, it says simulate having 3 kids. Do this 6 times. So instead of doing this just once, what we can do at the end of 1 comma 2, we can do comma 3. So now this is boy, girl, girl. Hit it again, and now it's boy, boy, boy. So we have boy, girl, girl. Oop, that's supposed to be a B. Boy, girl, girl. And then our second one was boy, boy, boy. Then we can hit enter again and get girl, boy, boy. Hit enter again. We can have all girls. and then I'll just do it 2 times real quick. All boys and boy, girl, boy. All boys, and then boy, girl, boy. So here we have a simulated probability. So our simulated probability that we have 3 girls, our simulated probability is 1 out of 6. Uh, the probability we have 2 girls out of 3, that happens once. Now this is, I should have maybe said exactly 2 girls, because that would just happen once there, so that would also be 1 out of 6. Now theoretically, those probabilities will be different, but in our simulation, they were the same. So there's different probabilities here. One thing we would just want to keep in mind is if you have more trials, it'll get closer and closer to your theoretical probability, and just a few trials, it can be a little bit off. But we'll talk more about that.